Hi, it's Trevor from GHD-repair.co.uk. We have a couple of GHD Platinum irons. Platinum is marked on the actual arm, and the model number is S8T261 on the label, but any model that says Platinum on the arm is not repairable. I've got two pairs here. They've been sent in for repair mistakenly by the customers who have not read the repair information page correctly, and all we do in this case is offer them a full refund, and we dispose of the irons for them. Obviously it's a great disappointment to the customer because these are pretty expensive irons, but once they're out of the 2-year warranty and they go wrong, there is absolutely nothing that can be done with them. In this particular case, I think it's a pinky colour. This particular pair, they will work normally 1 minute, and if you go to try and use them another time, they will just sit there making a funny bleeping noise. And this pair, it just makes the bleeping noise with the red light, and I'll just plug that in and show you a typical fault. And that's pretty much what they do all the time. Nothing makes any difference there whatsoever. So although we've got videos, pictures of the internals, I thought we'd just have a quick look and see how you actually take them apart. It may even be worth stocking or putting the used parts on the website in case a customer actually physically breaks anything, but probably not. But I've not looked at a pair of these, and on the face of it, it's not entirely obvious how you even start to get these apart. The only thing that I can see is movable is these sort of little thick rubber bands that go around the ends of the arms. Doesn't seem to be much else that can move, so we're just going to have a little look. Okay, so interesting, there is a little screw just inside there. If we pull that back, that you can see. I'm just going to undo that. Like I say, I've no idea how these come apart, so it's going to be interesting. So eventually, God, these are fragile. There's bits of plastic broken there already. There's 2 bits of plastic here. All that side's already come off. So you actually need to perhaps start from this end. Get a blade in there and just literally pop that off. It does not want to unclip down this end, and that's probably broken that plastic again. Yeah, it has. Oh, what an utter nightmare. Certainly were not designed to be repaired. Oh yeah, okay, now we have loads of screws. So certainly the hinge is held together with at least these 2 larger screws. Possibly that 3rd one in the middle there. I don't know why they've used. Oh no, that one goes right through to the other side, so that longer screw was holding this side together along with the screw halfway up. So the 2 bigger screws are actually securing the hinge mechanism. the smaller screw goes all the way through to the cover on the other side, so this cover. And I suspect if we unscrew the screw in the middle of the arm, these will now start to just fall apart. So yeah, there's the screw out that side, and this side. Oh, now we've just got everything falling apart. So we've got the metal bracket. There are the covers coming off. Still don't really know how that hinge comes apart. Let's get the metal out. Oh, interesting, a little bit of Captain tape on that alloy bracket. That's because there's wires running very close to it. I wonder why they haven't got it on the other side. Well, that is because it is just a ribbon cable on the other side rather than the mains carrying wires which are on this side. So I have thought about that. Now on this particular side we have the light and switch and the little buzzer. The wiring is actually on removable push-on connectors, which is nice. You literally just lift out like that. So there we go. A little closer look at the switch, LED, and the buzzer. Now I suspect that piece in the middle will come out now, will it? It still doesn't seem to want to come out. Ah, there we go, that's just, that whole arm has come off. You can see a big heat resistant pad in there. It's more of a cloth and fibrous cloth with a heat resistant covering than the old sort of felt pads on the older irons. This is definitely a more substantial material. It's securely held in place, as you can see. Right, so that's that. Now let's just pull this other arm off. There we go. So again, straight off with the arms. Now at this point, I wonder if we can get the plastic out now, which we can. Now the ribbon cables, or these flat film cables, run through this bit of plastic, so we're going to have to try and get that out. I'm going to take off the mains contacts, the mains wires still screw into the circuit board as they always have done. There is a difference though, because let's just pull that out a little bit. The terminals screw in to these soldered on sort of captive nuts, and on the old models the captive nut would be on this side and the wires would actually screw in on that side, and you can see that's what it would be on the older irons. But for some reason they've decided to screw straight into the captive nut, which seems a bit odd, because then you are relying on that, purely on that solder joint, to take up any pulling and stresses that are on this cable. Before, if it's screwed in this side, you've got a mechanical grip, through the PCB. So it's very strange that they would do it like that. Now let's see if we can get this off. I've got to gently feed the film through, and also looks like these wires need to come out of there. They're through a particular channel. There we go. So that's that piece out. Again, really very easy to damage this plastic. Okay, so that is then the cable socket arrangement. These springs, as you can see, are now screwed in place, and let's unscrew those. Not with that. We'll have a quick look at that cable and socket arrangement. This really is not a pleasant repair, even if we had parts available, which nobody does. Okay, so that's one of the hinge springs out. Even if we had parts available, this would be an utter nightmare to repair and try and put back together again. The chances of damaging parts are obviously huge. I think it's probably almost impossible to not damage the irons. So there's the little silicone pieces that allow the ceramic elements, the ceramic plates, to move around. So okay, now how do we get this apart? It looks, you can see in there, not quite sure what is holding that together. Looks like some sort of cover. There's a little silicone rubber cover, and it looks to me like there's two plastic tabs here, which we need to squeeze in, and then the socket and everything comes out from that way. So let's try that. We'll just squeeze them. Oh yeah, there we go. I've just squeezed those two bits of plastic either side, and the whole assembly pulls out like that. Oh, and then falls apart just like that. That is a nice substantial piece of alloy. It's quite heavy. It's most of the weight of the GHDs in that. I wonder how much the tooling costs to produce that. Yeah, interesting. And then the GHD lasered on there on one side. So yeah, there we go. That is the platinum cable, platinum socket, quite short wires, smaller than my other type 3 socket. Grease in there like all the like the Mark 3, sorry, type 3 cable. Yeah. So on to the bits that anyone would struggle with. So as you can see, we've got this thin film running everywhere that is bonded onto the circuit board. Yeah, if you look closely here, let's see if I can bring this up to the camera, get it focused. Yeah, you can see the piece here has multiple connections. Let me count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are at least a dozen connections being made here, and that would be very, very hard indeed to remove and refit without specialist equipment. Again, same this end, you can see all those connections there. Hopefully on this side we have 1, 2, 3, 4, 5, 6, 7, 8, there's probably 10 or so. Just trying to count all the traces I can see. 1, 2, 3, 4, 5, 6, 7, 8. There's at least 8 to 10 traces in there. Obviously we've got the same at the other end. They are protected with these little plastic clips, and there's a little bit of foam on there. A little bit of foam on that component there. Same this side. You've got multiple tracks on there, as you would expect. Again, very hard to get any of that apart and put back together again. You know, even if somebody came along and said, here's a complete element assembly, and all you need to do is unsolder the thin film and resolder it, it's really not going to be very easy. As I say, not even with the specialist equipment that I used to have, where you would you know, heat this up. You've got to be super careful, and then it's very, very hard to remake these contacts. So you can see the problem and why these are just not commonly repaired by anybody. Well, I'm not aware of anybody that repairs them. I'm sure there's a few people that will strip them down more efficiently than my first look, but I should have really thought about the fact that they want you're going to need to ping bits of plastic off. So that's quite a robust backing plate. And there is a thermal fuse. Now, interestingly, that is just in spring contact. I'll bring that up to the camera. You see the two long pieces here, they are literally just touching the thin film. So I'm wondering if that thermal fuse will just lift straight out of there. Actually, I wonder if we can take off this little silicon rubber piece. I don't know. Oh, I see, it's held in place either end. There's a bit of rubber and it's held in place there, so you need to pull the rubber back and pull that out. There's a little bit of heatsink tape, very similar to the stuff that's used on TVs. That's just to get the heat transferring correctly into the fuse. So, can we get this off? I don't know. Okay, there's another piece of rubber at the end. Okay, the whole thing's... Oh, that's interesting. So the whole element assembly is inserted somehow into this rubber, silicon rubber piece that we're looking at now, and you can see a little bit of thermal paste left on the actual plate. Not very much, it's absolutely dry. So even if we had elements, how do we get this out? Oh, okay, looks like you just peel that back and then slide the element out. Again, really fragile. This is really not something you'd want to be doing on a regular basis. So as usual, we've got silicone paste absolutely everywhere. Okay, now this is the problem with these irons. They have a tri-zone system. There are 3 tiny embedded thermistors, and so each of these 3 zones are monitored and temperature adjusted by the microprocessor. Just have a little close-up look of that. So if any of these 3 thermistors fail, or any of the, well, I assume it's 3 areas that are being controlled by each, you know, a single area for each thermistor. So there's 3 heating zones. Yeah, absolute nightmare. Be very hard to get that off. Hot air we could use to remove these connections, but yeah. The make is Timon, T-I-M-O-N, Timon Heaterflex, revision B. So, Mexico. Now I wonder if these are assembled or made in Mexico. Then it would make sense, wouldn't it? There is some sort of tape that's over the back of this don't know whether that's just protection or what that's doing on there. It's definitely a tape that's been applied, and there's also Captain Tape wrapped fully around the end here. Let's just move over to the other side. It's going to be exactly the same. The other end. Yeah, there we go, exactly the same arrangement. So now just pull that back and lift that out. So I suppose you could replace the thermal fuses, but I wonder if these are resettable ones anyway. Let's have a look. Don't know. Self-resetting, maybe, perhaps not. I'd have to heat these up and test them. Let's get that meter turned on. Looks like the only numbers that really make sense there is 2416, and that's probably week 24 2016, and then there is plus 230, so I'm guessing these are 230 degree thermal fuses. Now that one is absolutely fine, as is the other one, obviously. Oh, was it? Let's just check that. Yeah, it is. I think we would have to get some hot air on these and see what if they trip out and then reset later. I suspect they are resettable ones. We'll have to pop them apart or heat them up, like I say. I think we'll do that. Heat them up and see what they do. A little piece of rubber on the end there to remove. And then again, this whole element will come out, but you do need to release all of the thermal paste that's gripping the silicone rubber. There we go, and then just slide that out. So this pair was completely dead just with that red light flashing, so I wonder if there's anything obvious we can check. Yeah, no idea really. Nothing is marked, unfortunately. Yeah, very hard to get any readings off of this. That scrapes off. Don't know whether we scraped that off the other end. No, we didn't. There is a little piece of rubber that is lightly glued onto there, and that is covering up the contacts that you can actually get to. So let's see if we can just touch some of these contacts, see what we get. Absolutely nothing. That's interesting. So I'm touching the, let's try the other end. Okay, that's interesting. I suspect we have. There we go. Yeah, I was going to say I suspect the element is open circuit, so I'm touching on these thicker contacts, hoping to get something, but there is no reading whatsoever. But if we move over to the other side, I'll just use that thick contact at the end, and then there's 3 others this end. Nothing. Maybe I'm on the wrong one, so let's try the... No, I definitely had something a minute ago. Yes, that's broken. No, it doesn't feel it. I'm sure we had a reading a second ago. Let's try again. Fiddly to get onto. Oh, that is weird. I definitely had a read. Oh, there we go. So the 3 thicker pads there are giving me 313 ohms on any particular pair, so choose any pair of those and you're going to get 313 ohms or thereabouts. So on this pair we're getting absolutely nothing, sorry, on this 3 we're getting nothing, and as I moved that I actually noticed that the element is broken. There's very little in the way of thermal paste on here. I'm wondering if that is part of the problem. Yeah, if we try and get these cleaned off, there is a little bit of thermal paste residue left, but I mean it's absolutely bone dry. Is that a crack running all the way up? Yeah, look, it is. So the end is cracked, as you can see there, but there's actual crack all the way up, and if I bend that, the only thing that's holding that together is that it's Captain tape on the back. So as you can see, in this particular case, the reason for the failure is simple element failure. So there you go. That is the problem for this constant red flashing. Now I suppose if you bought enough of these irons, you would be able to salvage certain parts. The heating elements are exactly the same, I think, same code, so yeah, exactly the same. So you could take one of these off if you could physically get it off and reassemble these things, but wow, what would you charge for that, and how reliable is that going to be? That is a hell of a crack all the way up. I have to say, actually, these elements are really, really thin. If I grab an element from the Mark V's, in fact, I'm going to get the micrometer out and sorry, the digital caliper, if I can find where I've put it. So let's just check, let me zero that out, there we go. See how thick this is. So 0.85 of a millimetre, and the ones we're fitting to Mark V's are 1.27, so you know, a substantial amount different. I'm just going to grab an original genuine element, see what the measurement there is. It's much thicker. 1.3 in a genuine elements, and what did I say it was on here? .78. Wow, quite a substantial difference. So whether that has any bearing on the failure rate, no idea. So I think the next thing we'll do is probably end this video, because I'm certainly not going to attempt to put that back together. There's various bits of plastic that are broken, certainly these arms. Yeah, I don't know how on earth we're going to get those together again. Absolute nightmare. Anyway, so I think we'll perhaps move over to the hot air station and see if we can just heat this up and lift this whole assembly off. The other pair of irons is working intermittently, which is interesting, so maybe we'll take them apart as well. But for the moment, I think, well, look, a couple of things I think are of interest. Can we remove the element, and is this a self-resetting fuse? And I think we're going to have to heat that up and check it with the same hot air system. So anyway, a look at the GHD Platinum, and you can see why these are not repairable hopefully now, and whether it's worth listing any of these for spares, I've no idea, but yeah, anyway, hope that was of some interest, and we'll move over to removing this element. Okay, so we are back. I've just gathered the IU-852 up, and brought it over and plugged it in on this bench. We're just going to quickly clean up this silicone thermal paste. Which reminds me, actually, I think I got an email from somebody about the thermal paste being called silicone paste. Well, it's a silicone based thermal paste, but I think that might have been on YouTube, and I don't know whether I replied to that. Anyway, so let's see if we can heat up this connection and yeah, take that apart. Don't know whether we should try some. Well, let's pop a little bit of liquid flux on here. I can't imagine it's going to penetrate, but we'll give it a go. Let's just. So I've got this on medium heat and medium temperature. Hopefully that will be enough. Now I think I'm going to have to, holding it with my elbow and pulling on the element. Hopefully you can see that. I'm trying to look at the camera as well. Yeah, I think you can see that. That could be stuck on there as well. I'm going to turn the heat up a fraction and the air and move this across and see if I can, that's it, I'll hold it on the other end with my elbow and see if we can apply some pressure to this. Okay, just turning the heat up a bit more. Oh, there we go. Oh, there we go. That's come off quite easily. So as you can see, there are the contacts on there. So it looks like 1, 2, 3, 4 large ones and 4 small ones. There are tiny little holes punched through the 4 larger of the pads, I guess to get a bit of strength of the solder, you know, flowing through there. Now, let's see if this will clean up nicely. Yeah, well, it has cleaned up, you know, quite well. If we had a new one of these now, would we be able to reattach that? God, yeah, I don't know. The problem is the thin film. Yeah, I suppose you could, and hopefully that will just reflow. And then once it's tacked on, you could probably go onto each landing. Actually, every single one of those, even the tiny little square pads, have got holes punched through it. Absolutely tiny holes. So that's going to allow the solder to flow through there and you know, make a fairly good mechanical connection. So, interesting. I think what we'll do is we'll take apart the other irons and see, because we're going to be able to run these out of the body. We'll have to reattach the switches and lights here. PIC processor is there. much bigger processor. Oh, that's interesting. Fusible track, Timon control PCB, fusible track. So exactly what does a fusible track mean? It's exactly the same on the other side, fusible track, under a little label here. Timon power supply PCB revision B, Timon control PCB revision B, and but they both say fusible track. So in this particular case, the fusible track is marked on where the mains cable wires come in, and that goes straight along there, and that is exactly where the fusible track is written, and through this resistor. On the other side, the fusible track is not on a track, it is above this large one here, which goes off. Let's get that off. It goes off where? Oh, it's a pretty chunky track, it goes right the way through and under that, so I'm not entirely sure, but I suppose we could follow that. Oh, I can pull this up a bit. Oh, so it goes off to the other end of the AC in, so let me just follow that again, in there, through the resistor, yeah, through there. Actually, I could be wrong, let's have a look. Just follow it back, just the middle upper one there, straight into there, it's that big hold area there. Yeah, so actually no, it goes off up to this side, so yeah, it looks like it is the power to the element. So yeah, interestingly they seem to have used some sort of fusible track on the PCB. I'm going to have to look up and research that. I have never heard of a fusible track before, so that would be interesting. So yeah, I guess for the next thing we'll take the other pair apart and see if we can transfer one of the elements successfully onto this board and get it to work again. Yeah, anyway, that's part 2. Okay, back again with I don't know, part 3 of this video on these platinums. So the next question was, is this a resettable, self-resetting thermal fuse? I suspect it probably is, but the only way we're going to prove it is if we get some heat on here and get it to go open circuit. So we've got the meter on there. Oh, there we go, and you heard that click, and that has gone open circuit now, and hopefully in a minute that will cool down enough to open back up again, close up again, and we'll be absolutely fine. So yeah, no doubt that was a mechanical click. Hopefully that will cool down enough in a minute to reset. Completely wrong, and it is not a mechanically resettable one. Well, it's definitely cooled down now, so I guess I was wrong about that. Once that fails, it fails, or is it going to take a little bit longer? Interesting. Thought that would have been a resettable one. It's definitely stone cold now, so if it was some sort of bimetallic strip, that would have been okay now, and that is not okay. It is definitely open circuit, so haven't really got any choice but to open it up and have a look, I guess. So we're going to lift this cover off. Ah, is that? There's a little piece of plastic there. I wonder if this is a resettable by pressing it job. There's a little piece of plastic that came out there. Let's have a look. Let's pop that back in there. Well, you can definitely press that, but whether that's made any difference to the reading. Well, now the whole thing's fallen apart, so it does look like it's a bimetallic strip, so why didn't that reset? Okay, so that's very interesting. It looks like that should be resettable, doesn't it? There's an awful lot of work gone into a fail once and it's scrap. So I think what we're going to have to do is do that again, because I've got a sneaky feeling you might be able to press here if that resets, you know, if that's tripped. So let's try again. So perfectly good reading, and let's heat it up till that pops again. Heat back up. Yeah, turned down a little bit too low there. hasn't triggered. Oh, there you go. I think that was either plastic cracking or it triggered. Let's have a look. Yep, that is open circuit. So, is there a reset on the top? Press that in. I'm not sure. Maybe you've got to take it apart to reset it. Absolutely no idea. Never seen this type of fuse used in anything before. No, absolutely no idea what's going on there. Seems very easy to take this apart. I don't know whether it's supposed to be removable. Yeah, there definitely is a little button that goes through there. I've really no idea. If somebody knows, yeah, let me know. There's definitely a bimetallic strip there. I'm quite sure that's what that is. And what resets that? Yeah, very strange. Any ideas? Let me know. So I'm just back again with this fuse. And this little piece that fell out is like a little popper, whether you can see or hear that. But if you press it, it will ping back either way. So I suspect, in fact there is that hole with the piece of plastic, and that sits perfectly in there. And when you press it, you'll hear a click, and then that is then pushing that back all the way through. So that would seem to be the resettable part of this, but that is covered up by a metal cover like that. So this is yeah, very interesting arrangement. I don't really see how you'd be able to reset that. You know, you would think there would be a hole then in here that you can just press that back down, because this certainly doesn't reset on its own. You can see, hear that hopefully. So yeah, very interesting. Again, if that is the case, you have to take it apart to reset it. Excuse me, it really is not very easy at all. Yeah, interesting. How the hell would you get that back together again? I think that's the way around it would be. So even if you can get that in there and pop this back on. Is that going to be enough to hold it? Not really. That doesn't click or anything to hold these pieces together. And that's clearly wrong because that doesn't even go on there. That is not the correct way around. Actually, the contact must be that way up. And the bit that it's touching would be, yeah, would be this one. So that would be that way around. And then this, not exactly the same. Is it exactly the same? Yeah, I think it probably is. So that's then going to have to go back over there. How the hell would you get that together again? So it does appear to be resettable, but how the hell do you do that? Absolutely no idea whatsoever. I have to take another one apart and watch it a little bit more carefully when it comes apart. Anyway, that's the end of that one. Right, so GHD Platinum, we're doing this one as part of this look at the Platinum and all of its issues. This one will work sometimes and will not work another time. This time I plugged it in and it's, oh okay, this time it is working and heating up. That's normal operation with the white light flashing. Very often though this one will be sat there with a flashing red light like the other pair that we repaired earlier. So we're going to use the earlier video to get these apart more easily. But these are a problem. This rubber bit has to come off a little bit and the screw removed. Oops, that was more luck than anything else. These are very prone to tearing if you put too much pressure on them. So you've got to be careful. That's the other screw out. Now the way I found on the other pair was we've got to actually crack the plastic off, and it's not easy because other bits will try and break. So as you can see, one bit broken. We're going to pull that up. Yeah, there's little plastic pieces all the way along. Here, 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 there and there. And you'll see from this that 1, 2, 3, 4 of them have all snapped off and left bits behind. So the only way really of getting this back together again afterwards is probably with a little dab of glue. I mean, that's gone on okay now, but I don't see any way of not breaking these bits of plastic. They just don't seem very tough and not designed to be taken apart. So another bit of broken plastic, another bit there. Let's just try this side. That's tucked in there, so I don't really see how you can do that from that end. I think it's got to be this end. Yeah, let's click back in place. God damn. I've done it with my fingernails this time. Did we break any fewer? One broken there, one at the end, and bits at this end broken as well. I really don't see how you can get these apart without doing any damage, to be honest. You could use some double-sided tape like they used to use on the Eclipse model, or a little bit of glue, whatever you want. I mean, I don't think anyone's going to be repairing these anyway, so this really is just for information only. So you've got two thick screws that are holding the arm to the hinge spring. In fact, I'm probably going to tag all of these video clips together with Camtasia, and rather than have individual ones, it will just follow through, then you can get an idea of what I was trying to achieve. So there's a screw here, small one, and there's one halfway up the arm, and I suspect, well, I know that they are holding both halves of the arms together, and they will fall apart quite easily in a minute when these are taken out. But how the hell do you get these apart without doing any damage whatsoever? I've absolutely no idea. They look very, very, very fragile. These little plastic clips in there, I don't think they were ever designed to come apart. Right, so at this point everything is pretty much literally going to fall apart in front of you. So you've got the cover from that side, we have the got more bits of plastic falling out, silicone pieces from the arm. This side, as on the other video, you have the LED switch and the sound, and they just pull out of the main circuit board. Hopefully you can see, just lift up these connections from the top and pull them out and remove the switch unit. Now at this point there's a couple of alloy pieces just in here. One's got Kapton tape around it because that's where the main switch is. Sorry, the mains wiring is. Just get that bit of alloy out, like so. Even more bits of plastic. The other side will virtually fall out, but the Kapton tape is the mains socket wiring side. That arm will then pull off, this arm will pull out, and you can remove the rubber pieces if you want. So at this stage, this piece in the middle will come out like that. Line it up with the ribbon cable, flat flex, and actually I'm going to take the screws of the main socket off first. Hopefully you can see all this. You've seen the earlier clip of this anyway, so it's nothing unusual. It's just a shame you do all that damage to the plastic cover. Okay, so that is apart, as you can see. Just line that up and remove the plastic. Quite interesting how they would assemble this piece of rubber. What point does that actually go on? It sure isn't coming off very easily. Anyway, so the idea was to see if we could use an element from one of these on that other one to see if we could repair it. So what we're going to do, we will leave this intact. Maybe we'll use that in a while. We will take apart these assemblies, heater assemblies. It's also very interesting why this is intermittent. I wonder if we have got a crack on one of the elements. And we also want to investigate the thermal fuse, because it certainly looks resettable to me, but I don't know how that's achieved. So I'll be having a look. We've cocked up the other two that we took out. We'll have a look and see what's going on these two. So let's remove the ceramic plate. We will get these fuses out like so. A lot of heat. You've got the tempering colours. If you did metal work at school, you've got tempering colours all the way up these. So they obviously have got fairly hot. I don't remember seeing that on the others. No, that I took apart, but it's definitely heat colours on the on this one. Don't know whether you can see them or not. So I'll just get that bit of heat transfer stuff out of the way, and then we'll see about getting this out. So you do have to loosen that up. Just looking for any breaks in this. Looks fine. Very interesting to find out why these were intermittent. And same with this thermal fuse. Just lift that out. Again, I'll just lift off that bit of heatsink material, just loosen these up and slide this out like that. Again, no signs of any breaks. I wonder why this pair was intermittent. It's very annoying. Anyways, let's see if this rubber comes off. So yeah, it does now quite easily, so I guess that is the stage it's put on at. I'm just going to wipe off this. Now we know this pair is intermittent. We don't know anything about the other pair other than the red light flashes and the element is broken for sure, so hopefully we can assume that it's okay. So we are going to see if we can remove these elements. We've got some sort of foam material that clip and more material. This is more of a heat-sinky type material. This side is different, as you can probably see. Foam, quite thick, heatsink, fairly thin, but both sticky. We've got the plastic clip that covers that up, and we can check on the elements. The three contacts, they're all going to be reading, whichever pair you select, they're all going to be reading around 338, 344, 343. So let's get this one off first as well. I'm just going to remove that bit of plastic. Yeah, it's quite a hard plastic. Same from there. Just going to again remove. See, I mean, even if you had the parts, this stuff that you're taking off is not likely to go back on in with good contact, so I don't think this is ever going to be possible. Right, so what we want to do now is heat up this. Now, in the earlier video I used some liquid flux. This time I am going to attempt it with nothing other than the heat. We'll see what difference that makes, if any. Quite on that. There we go, that's off. We'll just spin this around. that is the two elements off, both intact, both with dried out thermal paste. As you can see, that is just dust, so we'll scrape them clean, and yeah, we have two good elements, hopefully. Why intermittent though? I'm not sure. I guess broken elements are not just the only fault that these boards suffer with. No damage done to any of the pads there. Still hot. PIC processor, well, this particular one is a PIC 32MX 120F032D. Programmable, obviously, if you've got the right gear, which we no longer have because we just don't do any TV repair work anymore. So all of my, well, virtually all of my equipment is long gone. Microscope, everything, programmers, rework station, the whole lot has gone because it just wasn't being used. You know, it's a ridiculous waste of money. It was interesting whilst I had it, but certainly not required for the GHDs that we repair these days. Okay, so really I guess we need to transfer one of these to the other PCB and see if that solves the problem. Doubt very much we're going to get them back together again. But we're not without missing, not without bits being left over anyway. So just taking all the bits off of this board. This must be an absolute nightmare to assemble in the factory. Little bits of plastic everywhere, little bits of silicone, tape. That's an interesting area just on there. You've got 8 little pads. Let me have a look at that. Guess that was for programming originally for the PIC processor. Yeah, P1 is labelled, so that is a connector for programming. Yeah, it's interesting. Glad I spent a bit of time taking a couple of these pairs apart just for a closer look. So we know we've got a fault on this circuit board. Not sure what the fault would be, and frankly I'm not really interested. Although having said that, it does look like that resistor there has got a crack in the end. It probably just looks like that, and it isn't really. It looks like it's poorly soldered. I haven't got my soldering iron on, but I'll investigate that later or another day. So yeah, anyway. So all of that can be put away. I want these two out, and the rest can go in a bag. So yeah, that's another little added bit, and we'll see if we can get one of these attached back onto that other circuit board. Should be interesting. So we're back again with the circuit board out of the first irons. We know one of the elements was broken there, and we're just looking at a way of reattaching this. Just wondering, because we've got the holes going all the way through these soldering pads, whether we can actually apply solder from the top. I think we'll just it's unplugged because I've been using the hot air. Let's get the hot air out of the way. And get the iron plugged back in. Okay, so as you can see, hopefully there are tiniest little holes through every one of those solder pads. I wonder if the solder, see, the problem is I'm not sure the solder will flow through them. They're so small. Now, thinking about it, that's not going to happen, is it? I think we will have to apply solder onto each one of these pads and then in turn try and solder them back onto the board. Okay, so now should we use some flux or anything on there, or shall we just, I think a tiny little bit of flux might help, just a little bit, nothing too much. And maybe if we do each one in turn, I think if we do the one at the end first, how the hell am I going to do this on camera? Let's see if we can just do this one at the end. Oh, it's so hard to line up even. Oh, and the whole board wants to tilt now, that's not convenient. What have we got to hold it in place? Did have some blue tack knocking around earlier. Let's see if we can get that board into the blue tack and stable. There we go. Probably at the wrong angle now. I'm trying to do this on camera, but it's not the easiest thing. So we've got to line them all up and then God, yeah, this is really hard. Well, it's glasses off time and a closer inspection there, because that is not easy at all. Try and get that blue tack off. That certainly did the job. So, well, certainly seems okay. I mean, it's not a perfect finish. I suppose we could reflow that now with hot air. But is there any need? I don't know. I'm not convinced there is. Yeah, they're definitely in and making contact. Yeah, I think that might be alright. I suppose the only way to know is to reassemble it and give it a bash. I think we'll just clean up those contacts a little bit gently with some ISO. Now, is there going to be an easy way to test this out? without getting everything reassembled. Well, I suppose we can... yeah, we're going to have to assemble the heaters, so... let's get the bits out again. So we've got the rubber, we've got the 2 heaters, and do some screws which I'll find in a minute. Let's see if we can get this rubber bit back on first of all. So it went on this way, wasn't it? It was tucked in. Yeah, tucked in this way. So the thermal fuse, yeah, literally in there. Oh, actually, it looks like that can go in at an angle. Now, sod it, let's just put it back how it came out, like that. I think, you know, even this isn't easy, is it? No, that can't be right. No, idiot. Plank. That's better. So, what secures that? Well, and which way round does that go? It's a good question. So, there's definitely more space there. So, that would be like that. And what holds that all together? Well, that is going to be the backing plate, and that secures everything. Now, what parts we've got for that? Is it one of these? 2 of these, perhaps. Not sure. See if that screws in all the way. Well, it does. Yeah, we do have 4 of them, so yeah, that must be correct. Okay, so we'll just do the same with the other side. I'm not really bothered about thermal paste or anything at the moment. We just want to just test these, see if it comes on where it didn't before. Actually, that's probably a mistake, because if it overheats, it's going to crack the newly fitted element as well. So perhaps we should apply some thermal paste after all. I'm going to put it onto the actual plate. Wipe that off, and then we'll probably go back and do the other side again. In the meantime, I've got the thermal paste everywhere. Okay, so where is the plastic piece? What do we do with that? Really? I thought we had that out. Okay, so let's get the element back in properly this time. Okay, so it's in there fine. Oh, I think. Maybe not. Let's have a look. Seem okay. Why didn't that want to go? That's it. So it's these two longer screws. Right, so the other bits we need will be the control panel and also the mains cable, etc., which I left somewhere else, didn't I, with the old one? Where is it? There we go. Yeah, the whole end is here. Actually, I think what I'm going to do is take this apart. Actually, I don't think we want this metal bit floating around. Just pull that out. I'll take off the little clip. That is not coming out very easily. No idea which way round this went, but it of course is AC, so frankly it doesn't matter very much. And we want a couple of PCB screws, which we've got there. Again, I'm wiring this in the reverse because the captive nut is this side, and this is the side that they have screwed the wires into, which again makes absolutely no sense to me whatsoever, because you are then solely reliant on the solder connection of the captive nut, and you have no no clamping force as if you would if you put them through from this side. But what do I know? So the next thing to do is replace the tiny little connections here, and they just push in from the top, so you put it in place and click down. Oh, it's fallen out of there now, so pain in the ass. I'm going to take the switch off in that case, because it'll be easier to work with. So you've literally got a ring of LEDs and the switch, and we'll just get that back in place. Literally just for testing purposes. Oh, that doesn't want to sit in there very well. Be a bit careful with putting that around. Now I've no idea what sort of protection we've got, and I doubt it knows that the audio, the buzzer is not connected, but we'll see. Right, so in theory that should be okay now, but let's find out. And I guess it is not okay, for whatever reason. No, exactly as it was before, despite the fact that we have connected up the new element, which was not broken. So guess what we can do now is just check the element connections. We were getting 3, 3, 4, something like that on every connection, and that is exactly what we've got on the new connections. We're just going to check for any shorts on the 4 little terminals. No problems there. So unfortunately I have no idea what the problem there is now, because we have fitted the new element and it is still not happy. I'm just going to check the other. Oh, what? We've got. No, that's not correct. Let's spin that over. So it looked like that was all open circuit, but that certainly can't be the case. God, it is. How is that possible? Got two broken elements? No, that was not how that was it, chaps? We have two sets of broken elements. Oh, I thought we only had one on this earlier pair. If that's the case, we're going to be changing that part again. I think we're going to call it a break. I call it a day there for the moment and go and have some lunch. So obviously I made a fairly basic mistake earlier and assumed the resistance was correct, and clearly it isn't. I suspect that these may be in. Well, okay, so every way round these are about 340, so that's good. This one is not good because there is absolutely no reading whatsoever, so we're going to have to get the hot air out again. So we're going to get the hot air out and remove this element. Well, I'm pretty certain this was okay, but it clearly isn't. There we go. That is that off of there. So now we need the other parts. Okay, so we will that's knackered, so we're going to chuck that in the bin. We need the other silicone piece. We can find it. Okay, so we are going to put the new element into here. And then we're going to bed it down into that. Like so, and we need the thermal fuse back in here, like that. Cover back on. Yeah, okay, and then we're going to put these screws back together. Find them. So we have a screw missing now. It must be in there somewhere. Oh, no, that's not it. It's just next to it in the bag. There we go. Right, so let's get this one assembled and then we'll check each element again. I was pretty certain only one had failed. So let's check the readings we get on here. Okay, so 3 terminals, 340, 340, 340, so 340 all the way around. And 170 if we go to the end large terminal and we go from there onto either 3 of these. So we've actually got 3 170 ohm elements operating there. Now if we go back to the other side, we should be able to check that is correct on this side as well. So 163, 174 or 179, so all pretty much as you would expect there. So we are now going to have to try and get this soldered up again, and I think we'll go for the same method as last time. We'll raise this up, see if we can get it to about the right height, just tilt it down so that is pretty much level with that thin film. We will remove the hot air system and plug in the soldering iron again. Right, okay, so let's apply solder again, just a little bit. It's not going to need very much, just got to take, we don't want blobs of solder on there. Probably had a little bit too much on the last attempt. That's it. Come on. That's it. Okay, so again, we are just going to line all this up, and you can pretty much see where it's supposed to go, and we're just going to solder that one. No, well, that's not going to do it. I think we're going to have to put a bit of pressure on the circuit board so it doesn't move much. And apply a little bit of fresh solder, perhaps this side. Maybe hot air at this point would be better. Okay, so I think that is that side done. We're going to work our way along, just pressing down. As we go. Just a little bit of flux I think might have helped there. Yeah, I definitely think flux would have helped. That looks pretty good now. Okay, so let's just clean that off. Yeah, just applying that liquid flux helped it to flow through and onto the board. I think we've got good contact now. Just clear up, whoops, I'll just clear up this surface again. And we'll see if that's made any difference. We'll be checking the resistance readings actually. I don't know whether the right, so we've got two known good elements. So let's check what we've got. So we just read it from the end one to any one of the three. And we've actually got 170, so these are all running independently, as you would expect, because obviously, yeah, of course it's that way, because you've got three elements, three thermistors on each side, so of course they're not connected. Stupid thing for me to say. That's what happens when you do this off the cuff. Expect you'll forgive me for that. Right, so we are going to go back to plug the mains cable in. We've got to plug the control switch in there. Try and stretch that out so it's somewhere easily reachable. We will put the speaker back in. Did I not take one out? Can't remember. This looks like it is glued in place actually, so maybe we'll just rest it there. Right, and without blowing ourselves up, let's plug these in and see if we've got any difference there. We know we have elements that are working now. We had a little white light flash, did we? Okay, so they are on and heating up. So yeah, that was the problem. So I guess very often this light flashing is going to be because of a broken element, and in my case we had two broken elements, just didn't realise. So yeah, job done. Yeah, interesting. So if we could get these assemblies, or buy enough broken ones, you probably could repair these, but geez, is it really worth the aggro? Probably not. I mean, the trouble is, if they failed once and they're going to go again, aren't they? I'm sure the elements are very, very thin. If you've got any sort of circuit board problems, you can forget it. There's certainly no code available for these picks, and certainly that is going to be copy protected. You're not going to be able to drag the code off of that and reprogram your own. And again, I don't know how much one of these is, but when you work it into a normal repair fee, you'd have to double the normal repair fee, I would think, to even start to look at these. And the other thing now is, without photographs of every stage of the repair, who the hell knows where to put these bits of plastic and the heatsink material. I've absolutely no idea where it all went back. I'd have to look at the video again, but I just don't care in this case. I was just more interested to see whether it was possible to transfer elements around, and yeah, it definitely is, as we've just proved. I don't know whether you got to see the white light or not. So that's normal operation, that just flashed white, and if you press and hold now, you get that tone, and then the lights are on and the elements are heating up. So yeah, there we go. Hope that was useful. Well, to be honest, it probably wasn't very useful, but it was probably a little bit interesting, possibly. I still won't be taking these in for repair, but yeah, I suppose we could stock various parts on the shop and possibly make up a few pairs, but this is not a nice model, just like the Eclipse, and I'm sure it is really not going to be worth the aggro. I can't really remember where these bits went, but yeah, does it matter? Probably not. Anyway, hope that set of videos was interesting. We never really got to the bottom of this resettable thermal fuse. Perhaps I'll take another one apart with a little bit more care another time. Let's see, we'll wait and see if somebody else sends me some platinums in by mistake. So yeah, okay, catch you all later.